Let's look at my Excel spreadsheet calculations. Actually, you know the drill, and it is the same drill as I did for the previous questions, but let's look at them quickly again. Remember, for the first time period, actually the data was taken from Yahoo Finance, starting from 2019 and ending at the end of the 2023. Remember, we are relying on the close values rather than adjusted close values. So the last value minus initial value divided by the initial value, and we have these monthly returns on Tesla stock. And based on these individual monthly returns, we are calculating the average monthly returns, both for Tesla and for S&P 500. S&P 500 data for the first time period will come from Fred database, again starting from 2019 and ending at the end of the 2023. Again, the last value minus initial value divided by the initial value. These are monthly S&P 500 returns, and I transferred these values next to the values for Tesla in this column. And also you need to calculate the average S&P 500 monthly returns given these individual values. And deviations from the mean for Tesla, remember these individual values minus the mean value. These are the deviations from the mean for Tesla, and do the same drill for S&P 500. These individual values, the average monthly return value will be subtracted from this individual monthly return values. And of course, because we need to calculate the variance of the return on the market portfolio, these deviations needs to be squared. So I take the square of these values for the algebraic long solution. And covariance again will be the sum product of these deviations from the mean for both Tesla and S&P 500 divided by number of observations minus 1, because we are looking at the past data and we need to rely on the sample convention. And actually what this formula tells is actually we are looking at the average of the product of these deviations. So for the first line, this multiplied by this plus this multiplied by this, and third value this multiplied by this. We are adding them up and dividing it by the number of observations minus 1. Actually what we are doing is we are looking at the average value for these product deviations. So the average value will give us the covariance, and the variance, remember, deviations from the mean are squared, and we are summing these values and divided by number of observations minus 1. Actually we are just again taking the average of these deviations from the mean squared value. This is the average deviation from the mean squared value, and which is the variance for the return on the market portfolio. And remember, beta will be covariance divided by the variance, 2.44. And of course you can rely on the quick Excel functions, covariance for the sample and variance for the sample as well. For the covariance sample, again, first array will be monthly returns on Tesla, and second array will be monthly returns on S&P 500. And variance, you can rely on the variance for sample for the monthly returns on S&P 500, so that we are getting the variance of the returns on the market portfolio. These are just quick Excel functions, and covariance value divided by the variance value, we will be getting the same beta as that calculated here. Of course, we can just do the linear regression. On the horizontal axis, we have returns on the S&P 500, and on the vertical axis, we have returns on the Tesla stock. So the data come from these two columns, and then just do the linear regression, and the equation of this linear line will be this, and the slope of this line is the same as that calculated in here, 2.44. And for the other time periods, actually we were following the same drill. Again, for this time period, the Tesla data will come from Yahoo Finance. Just calculate the monthly returns on Tesla, take the average for the long solution. Monthly returns for S&P 500, we relied on the data coming from investing.com. So just last value minus initial value divided by the initial value. These will be the monthly returns on S&P 500. And also when you will be downloading the data from investing.com, actually there giving you these change values. These are monthly returns actually. And as you will see, the values I calculated are the same as those shared by the investing.com. But I did the calculations anyhow. The last value minus initial value divided by the initial value. So these are the same value, and actually you don't need to calculate these, as when you pull the data from investing.com, actually they are giving you these change values. But in order to be sure 100%, I did the calculations additionally. And then again, this data will be transferred next to the data on the Tesla returns in here. And of course, calculate the average, calculate the deviations from the mean for Tesla and deviations from the mean for S&P 500, and deviations will be squared in here. And algebraic long solution, we have this sum product of these deviation columns divided by the number of observations minus 1, and for the variance, again, average of these deviations squared for the sample, of course. So that's why in the denominator we have number of observations minus 1, and beta will be covariance divided by the variance. And of course you can rely on the covariance S for the monthly returns on Tesla and on S&P 500. These will be your arrays. And for the variance S, you can rely on the monthly returns on S&P 500, and beta will be covariance divided by the variance. And of course, the linear regression, this is the equation of the line. So the slope of the line is the same as these values. So we are getting the same values again in different solutions. And remember, for the last time period starting from June 29, 2010 and ending at the end of 2013, for the Tesla, again, I used the information on investing.com. You need to do the sorting, by the way. So the dates should start from the oldest and ending at the newest, and then calculate the monthly returns for Tesla, and do the same for S&P 500. Do the sorting starting from 2010 and ending at 2013. Calculate the monthly returns, even though investing.com actually calculates these values for you. In order to be sure 100%, I need the calculations, and these values were transferred to this column. Take the average, then calculate deviations from the mean for both Tesla and for S&P 500, deviations squared for S&P 500 in order to calculate the variance. And for the long solution, sum product divided by number of observations minus 1 for the sample convention, and for the variance, average of these deviations squared, and beta will be covariance divided by the variance. Or we can rely quickly on Excel functions. As you will see, you are getting the same value. Of course, we can do the regression as well. Again, on the horizontal axis, we have S&P 500 monthly returns 5 years back, and on the vertical axis, we have Tesla returns. So this is the equation of the straight line. This is the slope of the line, and the slope value 0.55 is the same as those calculated in these previous solutions.